Hello, good afternoon, everyone. Today's we are fourth week of online problem solving session. So before start today's presentation, I will briefly introduce about myself. So myself Probir Maiti. So I am PMRF student from the Aijan Mohali, and I am taking that course Symmetry, Stereochemistry and Application. The course instructor was Professor Anshuman Roy Choudhury. So in this course we are talking about that symmetry, stereochemistry, and application. So first classes we are talk how to identify that organic molecule, how to name that naming of this molecule like that IUPAC nomenclature. Then we talk about that what are the point group present in that molecule. Then we talk about how we convert this molecule in 3D dimension to a 2 dimension, like how we convert this molecule Newman's or Hertz projections. Then we talk about that conformational energy of both conformation of cyclohexane or chair conformations, all of like earlier classes I have told about that. So today's classes we are talking about that nomenclature of this molecule. Earlier I have talked about that how this RS nomenclature can be mm, differentiate between two molecule, like two molecule are looking like a same but they are not mirror image to each other. They have the superimposable mirror image, and all of this molecule also their property are quite different, like you have shown, like thalidomide digester, like one molecule is which help in our body and one molecule which is bad for our body. So to know that RS nomenclatures, it will be very important to know the RS nomenclature of any molecule. So today's classes we are going to solve some problem related how we convert this bond OH or dotted bond or solid bond to a Newman-Sauer's projection. To convert this molecule that OH bond to Fischer projections, how we can start. So to convert this molecule, so first we have start from that general from left hand side, and from when you start from the left hand side, then what you are finding out, that you are finding out this, if you, when you saw from this side, so you will find that your bromine is right hand and your hydrogen will be left hand, and these 3 4 are in the below. So these 3 4 are in the below, one is the above, and your hydrogen in that at number 2 position. So first of all we have the numbering the carbon, it will be 1 2 3 4, and your 1 is the above, and you are seeing the molecule from that this side, left side. So if I saw, when you saw this molecule from the left side, your bromine is that right hand side. So how we draw? So first we are, so first we are draw this numbering. So like we are making this number 1 2 3 4. So then, so fissure will be like this. So first the numbering will be at 3 4. So this will be your 3 4. This will be 1. This will be 2. This will be 3. This 4. So first we are not direct convert to this OH bond to this Fischer projection. First we convert this molecule a semi-solid position like this. So this will be number 3 carbon, this will be number 4 carbon, which are connected. Number 3 carbon, number 1 2 3 is connected to the chiral center. So, and your hydrogen is the left side and bromine is the right side, and all of this like. So now you have to convert this bond to a Fischer projection. So this will be like this, your number 3 and number 1, this will be 1, and number 2 position your bromine will be right side, and number 3, number 4 as it is. So if you also see from this direction, so what you are seeing, your bromine will be right side and hydrogen will be left side, and here also your bromine you are seeing from this direction, your bromine will be right hand side and your hydrogen will be left hand side. So how you draw this OH bond to Fischer projection? So first you have to rotate this molecule such a way that the two bonds are coming towards you and other towards going in. Like if you rotate this molecule and you are making this OH and hydrogen is to your side, so how you rotate? So you rotate this molecule like this way. So when you rotate this molecule like this way, so your OH will be like this position, your hydrogen also coming up like this, and your methyl will be go there and use the C double H. Now they make the bond in the plane. So now you are making this one. Now you have to make this in the plane. So your methyl will be up, C double H below, and your OH will be left side. Now remove the chiral center. So now you have to remove the chiral carbon, and this will be your Fischer projection. Now you have to identify this molecule, that how will be your molecule if you draw this molecule is right or wrong. So these are that R lactic acid, how it will be R like this. Your first priority will be this one hydroxyl, your second priority will be this, and your third priority will be this. And if you rotate this molecule 1 2 3, they will be clockwise and your four priority is below. So this will be R configuration. Now if you want to identify this molecule, if you are if you draw this molecule in the Fischer, is this right or wrong? So now you go to the RS nomenclature. If you this will be give the R, then it will be right. If this could be give the S, then it will be wrong. So how you start? Then you have to pass that priority wise. This will be OH will be first priority. Then your COOH will be second priority. Then methyl will be third, and your hydrogen will be fourth priority. So now you have rotate. So how you rotate? 1 2 3. You were rotating 1 2 3, and your four priority in the Fischer projection. If you look horizontal, then the rotation, if the rotation will be clockwise, then that will be yes, and if the rotation will be anti-clockwise, then that will be R. So now the rotation is anti-clockwise and your four priority is in the horizontal, so this will be your R. So this will be your R, and original lactic acid also the R, so that are matching. So that we are drawn here, it will be right one. So from the west to that Fischer configuration, we are making the right. So now the RS nomenclature, how we nomenclature this molecule, the chiral center is R or S. So making a chiral center, you know already, so that must be a super impossible mirror image, that its mirror image never be mirror image never be same to each other. So first we have to identify the chiral center. So if you want to make that RS nomenclature, first we have to find out that RS, that chiral center. How the chiral center will be look like that there will be no, so there will be only E1 configuration. So after the so after you identified that chiral center, then you have to identify that what the chiral center it is. Or it is R configuration or it is S configuration. So if you first three priorities clockwise and your four priorities below the plane. So if your first three priorities rotate the clockwise direction and your four priorities below the plane, then that will be your R configuration. Similarly, if you first three priorities anti-clockwise and your four priorities below the plane, then the configuration will be S. Like an example, so if you draw like this molecule, so this will be your, like this will be fluorine, this will be your hydroxyl group, and this will be the dotted one. This will be that bot one, which will be that chlorine, and there will be some dotted one. This will be your dotted bond. This will be your hydrogen. So now if you go the priority wise, so this will be chlorine will be highest priority, fluorine will be second highest, this will be third, and it will be rotate 1 2 3. This will be rotate the clockwise, and your four priority is that this will be four priority which is the below the plane. So this will be your R configuration. Similarly, if you place this chlorine here and your fluorine here, then what will be? So then that will be, this will be first, this will be second priority, and this will be third. And your first, second, third is anti-clockwise, and four priority is that below the plane anti-clockwise, that will be your S configurations. So if you first three priorities clockwise and your four priorities above the plane, then that will be, that configuration will be S. Similarly, if your first priority in the anti-clockwise and your four priority is the above the plane, then that will be R configuration. Like this molecule, how we can identify. So this will be the first priority, this will be your second priority, this will be this methyl, will be third priority, and this will, hydrogen will be fourth priority, which is that below the plane. So if the below the plane, so that will be clockwise will be R, anti-clockwise will be S. Now we have to find out this will be clockwise or anti-clockwise. So this will be anti-clockwise, so it should be S configuration. oh no, sorry. So this will be rotate clockwise or anti-clockwise. This will be rotate clockwise. So it will be R configuration. Sorry. And the next one, that for the RS nomenclature, identify the chiral center, numbering them priority wise. First priority clockwise and fourth priority is the horizontal plane. Then the configuration will be S. So that nomenclature for the Fisher one. So if you first three priority and your four priority is the horizontal plane, this plane are vertical, and this side is your horizontal plane. Next we are try to solve how we draw that wedge bond to that fissure. So this will be easy. So that you first how you draw this one. So you are making this one like this wedge, and this one is that above the plane like this wedge, which is there above one. If you rotate, and your hydrogen will be this side, that left side. If you rotate this molecule like this, and your fluorine is up, methyl is down, and now you convert into that fissure that we already shown. So similarly, if you want to get that nomenclature of this fissure configuration, so how we can get? So if your first three priority clockwise and your four priority is the horizontal like this, your four priority in that horizontal position. So this will be your first priority, this will be your second priority, this methyl will be your third priority, and your fourth priority hydrogen is that horizontal plane. So now you rotate this molecule 1, 2, 3. So it will be rotate how? 1, 2, 3. It will be rotate like this direction, like that counterclockwise or anti-clockwise. And your fourth priority, so this should be R configuration. If this will be draw is right or wrong, how we can identify like this. So this will be a first priority, this will be a second priority, and this will be third priority, and it will be rotate which direction? That right handed, that clockwise direction. So clockwise direction means it will be your R configuration. So these are matching. So now we can identify that the chiral center is R or S even in that this condition, even in the Fisher condition. Then we can that track that this molecule we are drawing from OH bond to Fisher, is this right or wrong? So if so, these two we can do. Now we want to solve some problem. So first problem was we have to draw the Fisher projection of the following molecule and determine the absolute configuration RS of the chiral center. So you have to find out the chiral center. We have to nomenclature is that R or S or not. Then also we have to go that uh, how we can draw this molecule. So if you want to draw this molecule, so first you have to like this. If you want to draw this molecule, and if you show this molecule from this direction, and your at the first carbon, this will be first chiral center, This will be a second chiral center and this will be a third. This is not the chiral center, so there will be two chiral center only. So first chiral center where that NH2 is up. So NH2 up, if I want to draw this like this, and your first methyl you placed like this. If you are starting from left hand side, the methyl, and this will be a C double H. Now, if you start from these directions and if you show that at that odd carbon, your chiral center at the chiral center number one position, your amine is the up. So this will be left hand side. And in the next carbon, and if you find out that at the even carbon your amine is up, then it will be right hand side. So you have to remember two things. One is that where this in the chiral center is up or below the plane, above or below the plane, then you have to find out this which position, like it will be in that odd carbon or even carbon. If it will be in the odd carbon, then it will be in that left side in the Fisher position. If you will in that above, and it will be in that even carbon, and it will be placed in the right. So now we have to place that hydrogen. So now we have to draw this that Fisher projection. Now from this Fisher, if you find out that what we are drawing is right or wrong, how we can identify? So that we can identify by RS nomenclature. So how we can identify, like this will be a first priority carbon, this will be a second priority wise carbon, this will be a third, and your hydrogen will be below the plane, which is the fourth priority. Now 1, 2, 3, which are rotating, which direction? 1, 2, 3 clockwise, so this will be R. Now here this will be your first priority, this will be a second, this will be a third, and it will be rotate anti-clockwise for priority is horizontal, so that will be R. So that will be drawn, it's right. For the next carbon, this will be the first priority, it's 2, this will be your second, this will be a third priority. Now what do you find out? So 1, 2, 3 rotation each, 1, 2, 3 rotation is counterclockwise, and A4 priority is below. So this will be your S. So for this, which one will be first priority? So this one will be first, this one will be second, and this one will be third. And here it will be rotate 1, 2, 3. That is that clockwise, and your 4 priority in the horizontal. So that will be S. So above will be R, below one will be S. So those two are matching. So what we are drawn, it will be right, and the RS nomenclature we can give it. So if you know that UPAC nomenclature of this molecule, so the naming of the molecule will be 2S, this will be 2. So from here it will be start. So there will be 2S. So 1, 2, 3, 2S, 3R, 2, 3 dry hydroxybutanoic acid. And for these cases, 2, 3 diamino butanoic acid. So the nomenclature of this molecule. Now, So how we can make it more easy? So if you want to take that more easy, then how we can draw, like if you show this molecule and directly you can draw this molecule. How we can do like that? So to make the Fisher configuration like a just in 10 seconds. So how do you find out? If the OS system you draw from the left side, so if you're starting from this side, left side, and in the first chiral center, if the substituent in the above the plane, the Fisher substituent will be placed in the left hand side. So you start from left side, and if you find out that your substituent is placed in that above the plane, it will be placed in the left side. So just from here you draw this like this, you readily. So your methyl is above, you starting from there, and you will find out that your OH will be above the plane, so it will be left hand side. Just too easy. Next, if you in the OS system you would draw that left hand side and you are already placed the first chiral center. If you are already placed in the chiral center substituent in the Fisher system, for the next chiral center what will happen? That event center. In the OH, if a substituent placed in the above the plane in the Fisher, it will be placed the right hand side. If it will be above the plane, it will be placed right hand side. Side in the OS, if it is below the plane, it will be placed in the left hand side. Like this, if it will be above, it will be placed right side. In the even carbon, it will be. So how we can draw that much fast? So this, and if you draw these two chiral center, the above will be methyl, this will be COOH. So what I am telling, that above one will be starting from this direction. So above one will be left side if above, and the even carbon, if it will be above, it will be right hand side. If it will be below, so this will be left hand side. This. So if you draw from the left side, so what odd number will be placed in that left side, and even number above will be placed in the right side. And even number will below, that will be in that left side. That will be counterwise. So now we could draw this molecule. How easy we can draw this molecule. So we have to not finding out anything. So there will be first you find out how much chiral center. There will be two chiral center. So if you have two chiral center like this, so your methyl, which will be above, you are starting from methyl. You have placed already methyl. The above the plane fluorine, you placed that odd number above that left side, even number below also left side. Now we have to find out that RS nomenclature. This will be first, this will be your second, this will be third priority, and your 1, 2, 3 is rotate. How? 1, 2, 3, it's rotate clockwise. So, and 4 priority below, this will be R. Here, this will be first, this will be second, this will be third priority. So first, second, third, rotate counterclockwise. 4 priority is that below the plane. Sorry, not below the plane. This will be in a horizontal. So this will be R. So now this carbon. So this will be first. This will be second. CHF. This will not second. This will be a third. This will be a second. First, second, third. It will be rotate. How? First, second, third. So it will be rotate like this direction clockwise. So that will be R. There will be yes because your four priorities above the plane. So this will be first, this will be second, this will be third, and the rotation is clockwise. So this will be your S comparison. So both are matching. So that we are drawn right. Now the next one, how we can draw this. So this will be also too easy. Starting from this, how many chiral center? There will be one, two, three chiral center. So three chiral center we have drawn like this. This will be your methyl. So this will be your amine group. Amine group hard H plus CH2NH2. What I am telling, if that even one is that above the plane, it will be placed in the left side. That odd one and the even, it will be above the plane, it will be right side. OH. Now the next carbon is that odd one, so it will be placed left side, and this will be COOH. Next, we have to find out that RS nomenclature. What will be first priority for this carbon? First priority, this will be CH2, which is connected to NH2. So CN, and here it will be CO. So this will be first, this will be second, this will be third, and it will be rotate like this direction. First, second, third, clockwise. That means R. This one, the next one. So from here we can do. So first, this will be second, and this is your third, and it will be rotated like this direction. That is the counterclockwise. So that will be R. This one, what is your first? C, CH2, CH. Okay, and here CCl. So this will be your first. This will be first. This will be second. This will be third. So how we rotate? And this will be 4. I will rotate. So first, second, third, it will rotate like this direction, the clockwise, so that will be S. Now next one, so this will be first, this will be second highest priority, this will be third highest priority, first, second, third, it will be rotate anti-clockwise, this will be R configuration. Now for the next, so we can draw easily because now we know the rule, know the short tick. So this will be methyl. Now we tell this is a chiral center or not. Yes, of course it is chiral center. There will be no sigma plane passing to this. So this will be your chlorine. This chlorine up means this side. Chlorine down means this side. Above one is the methyl. and below one is COOH. Now you already know that RS nomenclature. So this your chlorine will be your first priority, this will be second priority, this will be third priority. And you know that first, second, third is rotating. First, second, third is rotating. Which direction? Counterclockwise. So that will be R. The next we can do easily. This carbon is chiral center or not? These are not chiral center. You plus the sigma plane from this here. So is that not chiral center? But these two are chiral. But if you find out that a center where, how we can give that RS nomenclature of this carbon. So you have above is COOH, COOH. Now, what do you get that? What do you get? So Br is the above the plane, it will be placed here. Next fluorine will be placed here. Next Br placed here. If these two are R and this will be S, then there must be sigma plane passing to here. You know that already. Already if you have drawn this, you have checked that the sigma plane passed to this molecule. So these are not chiral center, but is a center which may be chiral if these two position there will be something is changed here, this chiral center or this chiral center. So like this situation, so how we can give that chiral, this is the non chiral center but it will be chiral like. So for this we are giving this chiral center as small r or small s. So how we can get, so first we have to identify it like this one. So this will be a first priority, this will be C, the second priority, and this will be a third priority. First, second, third, it will be rotate. First, second, third. It will be rotate. How? Counterclockwise. So it will be R. Here it will be first, second, and third. It will be rotate clockwise. So it will be S. So above one is the R, below one is the S. The middle one should be small r or small s. So these two are same group, but that R1 we are giving one the more priority wise than the S1. So the fluorine will be first priority. So R1 will be the second priority, and this one will be a third priority. And hydrogen 4. Now rotate. So first, second, third. The rotation is first, second, third. Rotation is clockwise. So clockwise means, so it will be small s. Okay. Clockwise for priority horizontal. So it will be S configuration. So there will be big R, this will be small s, and this will be big S. Now for like allen system. So from the allen system, how we can give determine that RS nomenclature. So for the alene system, we have to see the molecule plane from the plane. So from here we are see what we are see that this will be above and this will be below. See the molecule from the plane and side, then placed it in the plane, and then plane side will be the above and below. The plane side will be above and below. So if I shown from this side, so this will be above and below, and this will be highest priority. This will be 1, this will be 2. So this methyl will be 1. So how we draw like this molecule? So first we see this. So this methyl will be first priority. This will be 1. This will be 2. So from which side we are seeing? Then how do you find out? Your methyl will be from here. Say you are seeing your methyl will be left side. So this will be left, and hydrogen will be like this. Now, so what you get? This is a chiral molecule or not? Yes, it is of course chiral molecule. The alene is chiral because in alene you have never got the superimposing mirror image. If you mirror image to this molecule, these are never be represent the same. So alene is a chiral, no doubt about that. So now we have to get that RS nomenclature of this molecule. So what you get? So from which side we are seen? So this side we are seen. So this will be your first priority. This will be your second, irrespective of that atoms what we are connecting to this molecule. Irrespective of that, from which side we are seen, if they are placed, this will be give your priority wise first or second. So this will be first, this will be second. Yeah, the methyl will be second priority, but we are not going to that. So what we are doing here, from where we are seeing, then we have to prioritize this one first and second, then the last one will be coming. So first we are seeing these two molecules. So prioritize this will be first, this will be second priority, this methyl will be third, and this will be fourth. Now you know that Fisher. So in Fisher, what we are doing like this, if we are rotating the molecule 1, 2, 3, that is 1, 2, 3, the clockwise. So if we rotate this clockwise, so that will be our conversion. So here we are not going by the Fisher. If we are going like normal condition, if it is rotate, it will be R clockwise. If we rotate anti-clockwise, it will be yes. So it will be rotate clockwise, so that will be R comparison. Now the last problem one. So how we can draw this molecule? Someone. So if you want to draw this molecule, so this will be also chiral. So this chiral is which type of chiral I have told already. This is the axial chiral molecule. So axial chiral molecule. So this will be chiral center, no doubt about that. Now we have to nomenclature of this molecule R or S. So first, from which side we are seeing? From this side. So what we are find out? Your amine is up. It is too easy. So amine is up, and your methyl is down. In between amine or methyl, which is your first priority. So amine will be first. This will be second. Now what do you find out? Your methyl is left side. So from this side you are seeing. So when you are seeing from this side, your methyl is left side, and your amine is that right side. So this will be 1, 2 already we are giving. So this will be third. This will be 4. Now 1, 2, 3. It's rotate anti-clockwise. So that will be yes. It's too easy. So today's is up to this. If you Repeat it once again. So what we are telling, so if you draw that Fisher comparison, so you have to like stepwise if you want to draw. If you want to draw that stepwise, you are making the two bond above the plane, like these two above the plane. Then you have to remove this chiral center and just place this one like as it is, like from here to here. Next, we have to give the RS nomenclature. If you rotate the clockwise, that will be R comparison. If the 4 priority is the below. Similarly, the next will be that for the Fisher one, what we are telling, if you rotate the molecule clockwise, 1 minute, clockwise, and you if you rotate the molecule clockwise, and if you find out that your hydrogen is in that horizontal, not the vertical one, so then this cases that will be S configuration. And if you find out hydrogen is the vertical position, then if you rotate the clockwise, that will be R. It's too easy. Draw Fisher, draw that OH bond to Fisher. It's too easy. If with the what carbon, it will be left side, even carbon, above, right side. This that two easy rule make that OH bond to Fisher configuration. Now we have solved some problem how to draw that OH bond to Fisher. Then we have to give that RS nomenclature of this molecule. So any doubt regarding this? If you no doubt, then once again, thank you. So please feel free to ask any doubt. This is my mail ID. Thanks. So we meet in that next week.